Okay, everybody, thank you for joining me today. We're having a few technical issues at the front here with getting the machine to toggle onto the projector for the demos, but I do have the deck here. So what I'm going to try and do is get it working in a minute. It's just doing a sort of a reboot. Once it's done that, we'll carry on with the demos as we go, okay? But in the meantime, we'll start on the slides anyway and take it from there. So forgive me for that, and I'll try and catch up with myself. So a bit of an intro about myself. My name is Chris Whitehead. I'm a PFE from Microsoft in the UK. So I work with Premier customers. There's a few of you or a few ex-customers that have worked with me in the past in the room here. We work on sort of proactive health, monitoring, looking after customers' environments, advising them on how to fix and troubleshoot issues with their environments. Some of you may have seen the session that Neil Hodgson's delivered, or a couple of those sessions. He's in my team as well. So we get quite good product exposure and quite good visibility to pain points that you guys have out in the field with the product, okay? A bit more about myself, team blog, email address, any questions and so on afterwards. I'm also part of the dev team for the SharePoint Risk Assessment Program. So if any of you are aware of that, that's a risk assessment program that we offer to our Premier customers to look at the health of your environments, which is kind of very related to this topic. So again, if you want any more info, please feel free to come and speak to me after the session, okay? Okay, so the objectives of the session today. So we're here to learn about health and monitoring, right? We're all here to learn about what's new, what's improved, what you can do to make SharePoint a little bit healthier in your environments. We all know the pain points in previous versions of SharePoint and how that caused problems in terms of, large lists, throttling, all those features weren't there. So hopefully you can learn something from me today and take that away and apply this to your 2010 environments, okay? But there will also be a deeper dive for those that are already familiar with some of this. So hopefully if I can get my demos working and this machine sorted, I'll show you creating a custom health rule, the HTTP throttling, how that works, how the health score works on the server, all those ins and outs of everything monitoring and performance, okay? So the agenda for the day, for the session, sorry. We're going to look at the unified logging service improvements. We're going to look at the logging database itself, creating custom reports, what's inside it, what do you get out of the box, and so on. I'm also going to take a look at the developer dashboard, large lists, and request throttling, the health analyzer. At that point, I'll try and show you how to create your own custom health rules. I'm going to try and keep it IT Pro based, but you will see Visual Studio, okay? I'm not a developer. Sorry, I'm not a developer, so no worries in the terms of custom code there. It's quite simple, all right? Health and admin reports, we'll look at that, and there'll be a bit on the end about SCOM and the new management packs and how that works with 2010. Okay. So ULS improvements. We're going to focus in on manageability, log file improvements, correlation IDs, and PowerShell Cmdlets. So this is kind of just a primer for what we're going to look at. How many people in the room are, just so I can get a rough gauge, how many people in the room know SharePoint 2007 fairly well? So pretty much everyone, okay? So just quickly, for those of you that don't know what ULS is, Unified Logging Service basically was something that came along in 2007 that kind of unifies all of our logs into one location. It's kind of responsible for the trace logs for SharePoint and logging to the event logs, okay? So when the devs in Microsoft write code, they output to the ULS service, which then outputs to the logs or the event logs, okay? So in terms of manageability, we've now improved the categorization of that. So previously, you would find that you're troubleshooting, you're looking in the logs, and you're finding errors that don't really map to Excel services, kind of under, say, timer service or a worker process or something weird like that. Now they've done a massive tidy up, and everything's categorized a lot neater and easier to see. Also, in the UI, you'll notice that we actually highlight non-defaults. So here you can see something's been changed to critical there, and it's been highlighted in the UI. So if you set, sorry, not critical, something's been flagged as critical is the level that will be shown, okay? So it's not a default value. If you change that to verbose or low or something like that, it will flag it in the UI so you're able to see what's changed and then change it back if you need to. I've been on site with customers where their logs are growing at like 4 gig every 30 seconds because they've got everything set up to verbose, okay? So this helps with that quite a lot. Previously, to change the logging levels, it was STS ADM commands, right? So it's now UI-based. You can also see the reset to default option here. So if you do go raise a support case, do some troubleshooting, and you change all of these, you can just hit that, and everything goes back to medium and information, which is really handy. Log file improvements, so event log flood protection. How many people had the issue where you had like 6398, I believe it was, and 7076, and there you go, hand, and everyone should probably have their hand up. Now that was an issue with IIS and the ADSI provider, and there's a hot fix for that. If that's news to you and you've got the issue, then come and see me after. But that would flood your event logs, like literally 3 events every minute, just kill the event logs. Now there's event log flood protection built in, which means that if an issue by default fires events, more than 5 times in 2 minutes, we'll actually throttle that back and just fire another event that says, this event has fired 400 times, but it's being throttled because it's flooding your logs, okay? So that's pretty cool. That is fully configurable, so you can use the set sp diagnostic config PowerShell cmdlet to go in and configure that and change it to whatever settings that you prefer. And in Central Admin, it is literally just a case of ticking the enable event log flood protection, which is ticked by default, so you're pretty much good to go out of the box with that. There are some scenarios, and we'll come to that later, such as with SCOM, where you can see that doing that may intercept with monitoring software, and you may need to adjust these things or turn it off completely. A good example of that is the 5586 error. So if you've got database connectivity issues, it will fire off hundreds and hundreds of events. 379 more times it was suppressed. That actually fires with 2159. So if you ever see a 2159 in the event logs, you know it's a suppression message, and the underlying message is within there, okay? Event log entries also logged in ULS. So previously, if you had an event log issue, it wouldn't log in ULS and vice versa, right? Now, if something's logged in the event logs, it's normally because it's fairly critical, there's a problem, right? Now they go into ULS, and the IDs match in ULS as well. So you don't get these random like 4XY5 type IDs. For anything that has got an event log entry as well, you actually see the corresponding IDs, and I will try and demo that if I can get this working in a minute. Size reduction. So we actually use NTFS file compression by default on the logs directory now. So out of the box, you shouldn't have massive, large log files that are spanning, gigs of data. They should be at least 50% less in size. And that's not just because of the file compression, that's also because the way we've optimized the amount of logging we do, when we log, and so on. There's also a longer retention. So it used to be 2 days by default. It was, 96 logs on a rolling 30-minute window. 2 days, not really brilliant. You get the problem on Friday, you go home. By Monday, you've lost all your data, right? Now it's 14 days by default, so we capture the data for a lot longer, which means for Microsoft and for the support guys and for anyone that deploys this stuff, you're able to go back and look at this for a much longer period of time rather than relying on grabbing the logs manually and making sure you've got them archived off. And we have ULS to LoggingDB to SCOM integration. So what actually happens is, and we'll come on to this when we look at the LoggingDB, we can actually take the ULS logs by default, and it will push them into the logging database and any of the entries that are above a certain level. So we can later on go back, even when the ULS logs have been deleted, and we can mine that data from the logging DB and use that to look at problems, look at, if you've got a case open in Microsoft, you can send that off to them and they should be able to help you, okay? And there's a lot more that goes into the logging DB, and we will come on to that. And then there is the fact that obviously SCOM can pick up anything that's in this database as well if you point it at that and you create your own custom rules and so on. So it's pretty good. Out of the box, you do need to do some work to speak to the logging DB, and I will try and demo an Excel report that shows you that as well, okay? The other feature is third-party logging can actually be integrated. So you can actually log to ULS now yourself. So if you've got your own application that hooks into SharePoint, if you're an ISV, a vendor, someone that writes your own code that you're selling on a product, you can actually log that into the ULS logs as if your application was part of the SharePoint infrastructure, which is pretty cool for those vendors because it means they don't need a separate logging system for themselves now. They can kind of have it all in one place. Okay, so moving on to correlation IDs. This is a very new feature, and it's very, very handy for troubleshooting. So now every single request that is fired off, so if a page is hit, has what's called a correlation ID associated with it, which is basically just a GUID. We know how much the SharePoint product team loves their GUIDs. We use them again here. So when I make a request, that actually fires off, does all the work in the back end, does all the work on the front end. If there's an error, you've all seen the unknown error occurred message, right? You've all seen that and like, what's going on? There's now a correlation ID, and that ID you can search for in the ULS logs, and that will find those entries in the ULS logs for that request. So there's no more of this scrolling up and down the ULS logs to find what you want. You can just filter and search on that correlation ID. They're shown on the error pages, shown in ULS, and shown in the developer dashboard. And if you haven't heard of that, again, I'll try and show that to you shortly. So how does the correlation ID infrastructure work? Now, consider a scenario where you've got a web front end, application server running, say, Excel services or the web application components, and your SQL server, obviously, in the back end. Now, there's obviously going to be hops going on as the page is rendered, Excel does a bit of work, the database does a bit of work. How does it kind of work? Well, the user makes a request, ULS gets an entry logged with that correlation ID. The request then pushes through to the application server. So Excel might do some work. ULS on that server has that correlation ID logged as well. What actually happens then is it returns back to the web front end with the information. Again, correlation ID still stays with that request all the way through. And then we can push that back to the client. So what actually happens is the entire length of the request, we've got the correlation ID stored. In fact, if you open up SQL Profiler, you can actually see correlation IDs in there as well. So there's no way you can't find what is going on for each individual request. And then, like I said, you can search across the 2 ULS logs, find the entry you want, and you can troubleshoot the issue a lot easier than you used to. So there are some PowerShell cmdlets for this. I'm going to try and demo them. We've got some configuration ones for the diagnostics config. So we've got get and set SP diagnostic config. We've got the log file control option, so new SP log file. So we can actually issue a PowerShell cmdlet, new SP log file, and that will cut the current log file and start a new one. And that's great, because if you're doing an upgrade or you're doing some troubleshooting or a patch, you just run that command as part of the procedure for that, and it guarantees you've got a new ULS log cut at that point in time, so you know you can start troubleshooting from then on, which is quite a handy tool. Merge SP log file as well. This gives us the ability to actually merge log files across the entire farm into one log file and view the contents, or across one server. So we can say, right, get all of the log files across my 10 servers across the last 5 days and put them into one giant log file. Pretty cool, right? Get SP log level, set SP log level, kind of does what it says on the tin. That's to get and set the levels like you saw in the UI. That's a direct replacement for the STS-ADN commands that used to allow you to do that. And then the clear SP log level is just setting everything back to default, okay? Now, trace log querying, we can actually use the get SP log event command. So we can actually query the logs like we're doing a query against a text file in PowerShell, and we can say, right, query on ULS ID or date and time or machine name, and it will search all the logs for that entry from a PowerShell cmdlet, okay? So again, pretty cool feature that is. Now, I'm meant to be doing a demo of this. Let me just see if I can get this working quickly. Apologies if I don't. Like I said, what I might try and do is do this in a session tomorrow when I'm meant to be doing something else if I can't get these demos working today. Okay, that is not going to work at the moment. What I will do, I'll get on with the slides. I'll try and get through the session. My apologies. I have no idea why it's not working. I think it's actually an output to the projector issue. The laptop has been absolutely fine. I don't think I'm going to be able to do demos just because it won't toggle to the projector right now. Like I said, what I'll do is I'll get through the slides and I will try and either pick up this with a demo. We've got some free time tomorrow afternoon. I'll go through the demos tomorrow afternoon if necessary, just to make sure that you can all see this, because the demos are really kind of the key piece to this. So the logging database, it's a central store for all SharePoint health and usage data. So we have this usage and health data collection service application, right? And that is responsible for all of the logging to the logging database. Now, the logging database pulls data like feature usage, ULS, event logs, and everything into it. So you can see here we've got like performance statistics, SQL DMV queries, crawl and query statistics, timer job usage. All of this info of everything that's going on in the farm is pushed back to this logging database. What that means is we can do some kind of retrospective troubleshooting with it, but we can also use it for like performance statistics. We can do kind of web trends analysis on it. We can do all of these things that you've always wanted to do with SharePoint. And the API, the info is there. You just need to know how to get it, right? Now, it's enabled by default. There's a customizable retention policy. So by default, it's 14 days. So 14 days this info is logged for. at a detailed level, and it can be stored for longer, up to I think about 365 is the latest information I've heard in the RTM build. But the cool thing about it is the schema is public and documented. So you can actually go in and modify this database. Now you might hear some, ooh, SharePoint doesn't support that. It does in this case, okay? It is fully supported in this case to modify the schema, provided you kind of, you know, you're not going to go in and change some of the out-of-the-box things to stupid values that are going to break it, right? But as far as Microsoft are concerned, it's a complete throwaway database. If you mess it up, you just create a new one. You lose that logging data, but it's not the end of the world. So you can actually write your own providers that will push data into here. So again, if you've got your own custom application, you can write to both the ULS logs and you can write data directly to the logging database. And you can pull data directly out of the logging database into something like Excel or a data warehousing solution or a web part, whatever you want, okay? So there's two categories to this. Usage and health data is kind of how you would split it up. Now, physically, you don't really see these two categories in SharePoint, but in reality, there is, because there's different services that are doing the work under the hood. So the usage data is logged to binary files first. So just strictly speaking about usage data, any data about feature usage, requests, so not web analytics data, but you know, requests for pages, who's done it, why they've done it, more from a diagnostics point of view, is logged to a usage file. And that .usage file is stored in the 14 Hive under the logs folder. And that's in a binary format. You can't open and edit it out of the box or read it. And you get basically one of them every 5 minutes by default gets created, and then once it's been imported, it just gets deleted. And that is what's used to actually import the usage data into the SharePoint 2010 logging database. Now, you can use the set SP usage service to control the usage log files, how often they get cut, how often they get imported, and so on, okay? Really, how you or when you would change that depends on the size of the environment. If you've got a lot of users coming in, a lot of web front ends, and a lot of data going back to that database, then maybe you want to customize that. The database was written in such a way that it's been optimized for up to 5K IOPS on it. So it's a heavy write database. It's not very heavy read at all, but we're expecting up to 5,000 IOPS on it. So we're kind of recommending separate spindles, you know, separate storage for that database. Now that seems a bit of a shock to a lot of people because they think, oh, it's just a logging database. But if you're going to use it aggressively, then clearly, if you're logging, you know, millions and millions of requests and millions of rows of data into this database, you need somewhere to store all that, and you need to be cautious of performance, especially if you're sticking it on the same spindles as, you know, content DBs or search in your temp DBs, for example. There are PowerShell cmdlets for this as well. Set SP diagnostics provider and set SP usage definition. Diagnostics provider allows you to say, right, I want to set the, so like with SQL DMV queries, the performance details, the event logs and the ULS logs, all the diagnostics data, you can set when that gets pulled in, how long it's stored for, and so on. And the usage definition cmdlet allows you to specify which of the usage elements that you pull in and when, okay? Again, demo would help showing that. So a bit more about the logging database, though. Health data is imported directly from source by a timer job, basically. So each diagnostic provider, each of these here, SQL DMVs, trace logs, SQL blocking queries, we grab all of these by default, and they get pulled in by a timer job. Each one has various different schedules depending on what it is. So the perf stuff's pulled in like every 30 minutes by default. The SQL stuff, blocking queries, is pulled in a lot quicker. It's like in the seconds, because that's kind of more important to log that information. Basically, their timer jobs, they just keep running in the background. They keep putting that data directly into the database. Again, the diagnostic data stuff is kind of a timer job that pushes in. The usage data is the usage files, okay? It's important to be clear on the separation between those two. So heavy load, simultaneous writes, okay? That's kind of what's expected of this database. So again, if you're planning on using this aggressively, you probably want to look at how you're gonna plan for capacity and performance on that database. I mean, you can turn it on, play with it, see how quickly it grows in your environment, right? And if you realize it's causing problems or it's getting quite out of hand, you can turn on and off certain categories or how long you're logging for, right? If you're having a SharePoint deployment that's kind of just a deploy and run away, don't monitor it, then maybe there's an argument for not having this. If you're going to be proactive about it and you want to look at this data and mine it, then you're going to have to look at this. So health reports. Now, Now, out of the box, we actually ship some reports that allow us to pull this data from the logging database. Now, I'm not too sure about the internal Microsoft side of why we didn't do as many as I would have hoped, but that isn't that many reports out of the box. Now, again, it's an open schema. You can create your own reports for this, so I would expect a lot of community content on this side of things. But out of the box, we basically get a couple of reports. We get longest or slowest loading pages, basically, so we can view all the pages that have rendered and how slow they were at rendering, and top users. So they're the kind of the two admin-type reports that we get out of the box. Again, you've got all sorts of data in there, so you could mine things like whether people are using IE versus Firefox, you know, whether you've got performance issues, whether a certain event ID is being logged more often than others. All of this stuff is you can pull it out of the logging database. SharePoint ships with those two reports out of the box. I'll show you a quick, I think there's a screenshot of that. So in Central Admin, if you go to the reporting section under monitoring, hit view health reports there, you'll get a report like this. So this is the slowest pages. So you can see here in this case, we've got 22.991 average duration for the home page. I think I was just warming up the server at that point. And you can see the maximum was 91 seconds. So this data is there. It's handy for you to go back. And if a user says, oh, hang on, SharePoint's not performing too well, you know, you've got this data out of the box to go and verify whether that is the case. And whilst this doesn't give you what the reason may be, the logging database is guaranteed to have that in there, whether it was SQL memory problems, performance counter issues, events firing that are indicating other problems. You can get that based on looking at a basic report like this. Admin reports. So I don't know, again, I can't give you an answer why these are separate categories, because to me they're kind of the same thing, right? But there's an admin reports section in Central Admin, and I've actually read the spec on this as well internally, and there's no clear indication as to why we kept them separate. I'm hoping that there's some guidance comes out when TechNet gets updated with information as to when you would write reports for each category. But admin reports basically pushes, at the moment, all the data about search into the UI. So we get things like crawl rate per type, query latency. If we go into advanced reports, we get things like the crawl queue, processing per activity, and so on. We click on these reports and we get pretty impressive data, right? So we're getting things out at this point like query latency in this case. So when we're getting query latency issues, and this was actually a MSIT internal example. So across 3 days here, we can see that we were getting spikes, you know, throughout the day, slowing down late at night, obviously, and we can then go in and say, well, do we need to optimize things? Do we need to add more query servers? You know, what are we doing right and wrong here? So again, out of the box, it is quite rich, but this is all coming from the logging database. So it kind of shows that you can write these things yourselves if you don't have the information you want. So again, demo on the logging database. If we get time at the end, I'll try and fire that up. Worst case, what I can do is I can boot into my Windows 7 machine and at least show you some of the demos on that, okay? The developer dashboard. How many people here have seen the developer dashboard, just so I get a rough idea? So a fair number of you. Is that in session so far or before? A bit of both. Okay, let me just... So the dev dashboard basically allows you to look at diagnostics information for every single page that gets rendered. So how many of you have had issues where you've had slow page load and it's kind of a dev's made a bad web part or a user's trying to do something really stupid? A few hands, right? We've all seen that pain. Well, now with the dev dashboard, we can actually see everything from the full stack trace of the request that was making the call, the database query that was run, the time that it took in milliseconds for each of the components on that page to actually load, and which component was causing the slow loading, for example, right? And again, at the end, when this is rebooted, I'll be able to show that on my machine, hopefully. It eases the diagnostics of page-related performance issues because although it's called the dev dashboard, for admins, you can turn it on and you can then blame the devs for writing bad code, right? It kind of works both ways. And it shouldn't just be aimed at the devs. It should be something that you use in your tool set to troubleshoot performance issues when a user says, hang on a minute, I'm getting a slow page load. It's pretty conclusive where it's coming from when you look at the results from that. It's turned off by default. Now, you'll notice I've got an STS-ADM command here, which is probably like the only one at the whole conference. The reason for that is the PowerShell command to turn this on is a lot longer-winded and a lot harder to issue than the STS-ADM one. In fact, I might just get that up to show you here. So in the notes down here, you'll see that's kind of the way you would do it in PowerShell, which is obviously a lot more long-winded than doing it in STS-ADM. So what I would say there is, if you want to turn it on, probably STS-ADM is the best way to do it, but if you kind of like using PowerShell, off you go. I have seen some community solutions where they've added a custom solution package basically that goes off and will add a piece of functionality in central admin that allows you to turn this on and off in central admin. For some reason, we didn't add this functionality into the UI that enabled you to turn it on and off. Now, what the dev dashboard does when it's turned on is it puts a little icon in the top right-hand corner if you set it to on demand, and you can click on that and then view the output of the trace information for the page. If you set it to on, not on demand, it will always render for all pages, and if you set it to off, which is the default, it won't render. The important thing to note here, though, is that it only renders for admins or site collection admins. So not every user is going to see this page trace information. It's only if you're getting an issue. It is a server-wide setting, though. So when you enable it, all web apps, all site collections, everything will have it enabled. But again, it's only admin scoped, so you shouldn't have an issue with using it as and when you need to. So again, a demo of that. Like I said, I'll reboot and be able to hopefully do this in my Win 7 machine. Resource throttling. So one of the biggest pain points in V3 was large lists. How many here have suffered from large lists? Good show of hands. Okay, and underperforming servers, right? Normally caused by 32-bit servers with lack of memory, probably, maybe not really necessarily lack of memory, but lack of memory to render the web parts that are not disposing of objects properly. We've kind of all been there as well. Now, SharePoint 2010 includes a couple of pieces of key functionality here to help address that. List view thresholds is one of them. So now when we render a list, if we get past the threshold, which is 5,000 by default in SharePoint 2010, it will say to the user, nope, I'm not rendering this data. You are actually trying to issue a query against the SQL Server that's too resource intensive. Go back, modify the view, set it so it's viewing less data, and then maybe delete some items or change what you're viewing. Can anyone tell me why in 2010 it's 5,000? Why is 5,000 a good figure? Nope. So the reason why we chose 5,000, and previously obviously the guidance was like 2,000 is the recommended limit, is because at 5,000 is when SQL Server 2005 or 2008 actually starts to escalate locks at the row level to the table level. So by default, when we get to 5,000 items being pulled back in a single query, we escalate to a table level lock. So it makes sense that in SharePoint we kind of go along with that and set it to 5,000 by default. Now, I would argue that if a user needs to view 5,000 items at once, it's kind of negates the point in having SharePoint, right? Although, obviously, when we look at all items view, for example, we don't see all 5,000 items. We paginate, we see like 1 to 30. And this is a common confusion when it comes to large lists. It's not that we're viewing 5,000 items at once. To be able to paginate it in that way and to sort, if we want to sort A to Z, for example, we still have to pull back all 5,000 items, and then we can show 30 on the page, but we can't sort it unless we go to SQL and actually pull back the full 5,000. So that was why it was more of an issue than people originally kind of thought in 2007. Now, another cool feature is HTTP request monitoring and throttling, and again, I'm going to go into that in more detail in a minute, so I'll skip over that for a second. So again, going back to the large list view thresholds, 5,000 by default. There is an object model override. So we can actually say, right, admins, developers can, by default, have up to 20,000 items returned if they're doing object model coding against it, right? That's so that maybe, I don't know, they need to pull this data for a report, or they need to pull this data because they're customizing workflow history or something like that. Again, we've all seen these sort of pain points. So we do have the ability to have certain power users access larger subsets of our data in a view than the standard 5,000, and these figures are completely configurable. There is also a happy hour, as it was kind of branded, for large queries. So we can say between 11 and midnight, we don't care. You can go and render 25,000 items in a view. Maybe you've got a tool that needs to do that. Maybe for some reason you're trying to fix a problem that started off as being a large list, and to do that using this happy hour window is probably a good time to do so. Going on to HTTP request monitoring and throttling, designed to protect the server during peak load. So think of it this way, your server starts to struggle, it's low on memory, it's low on CPU cycles, it keeps getting hit, SharePoint can't recover from that, right? Unless your load balancer's got some logic built into it, SharePoint can't recover from that. And even if your load balancer has got logic built into it, it may be some bad code or a long-running operation that's causing that, and it's just never going to recover. In 2010, HTTP request monitoring allows us to basically monitor the state of the server and say, right, have we got low memory condition? Have we got a large number of items in our ASP.NET request queue? If we have, throttle them. Stop serving requests. Stop serving requests to the search crawler. Now, obviously, we need to be careful about what we're stopping requests on. Stopping requests on the search for the search crawler makes more sense than stopping requests for users, right? And if a user's in the middle of doing an upload of a 50 meg file and they're on the WAN, they're going to be a bit annoyed if SharePoint just goes, hey, server overload, sorry, you can't finish uploading this. So we're a bit clever about how we do this. GET request will receive a 503. So out of the box, GET requests from a crawler by default have a lower priority than GET requests from a browser, for example. So we analyze the agent string and we say, hang on, crawler no, browser yes, at certain levels. When we just get to complete shutdown, we just say it right, all GET requests, let the server recover, block them. Timer jobs can't start, so we say, right, timer jobs, let's just stop them from starting, don't allow any long-running operations, let the server catch up with itself, and search is throttled and so on and so forth. But any put requests are still allowed. So if a user's in the middle of doing an upload, they can still finish that upload, for example. But obviously, to do an upload, you need to do a get on the page that you're doing an upload from. So the point is, you can't just keep uploading data. You can only finish the upload for the session that you've got started, which is good, right? That's what you want. If you're uploading 100 items, you want that to finish. You don't want the server to kill your session because, you know, it's a bit upset with the performance. Now, out of the box, we base this on 2 perf counters. Previously, in other conferences, like the SharePoint conference, there was speak of the CPU being included. I have no idea why it was dropped, but these 2 kind of make the most sense given the issues that they would cause. Available memory and ASP.NET request queue. If we get to certain thresholds on them, we basically start throttling, okay? And I'll go into the ins and outs of how that works. But basically, we check these perf counters every 5 seconds, and if we get 3 samples over the limit, we then start throttling. And when I say we start throttling, we don't start throttling on a blanket level, just throttle. It depends on how much available memory there is. So we actually use this idea of kind of buckets, and these buckets contain information saying, if the server's on 100 meg, it's got a health score of 1. If it's on 75 meg, it's got a health score of 2. And I'll kind of show you that in a second on the screen. As soon as we go 1 sample under, though, as soon as we get into a healthier state again, the server's back open up, it's able to carry on performing those operations that it needs to. Again, this is fully configurable, so we can actually use the get SP web application HTTP throttling monitor command and the set SP web application HTTP throttling monitor command to get and set this information. Basically, that is a screenshot of the get SP web application command there for the HTTP throttling monitor. And we can see here, for memory available megabytes, we've got an associated health score calculator with 10 what we call buckets. Health score buckets. So on a scale of 0 to 10, if the server's got a gig or just under a gig of available memory, the health score's 0. If it's got 20 or less by default, the health score's 10. So we start throttling. We only actually start throttling when we get to 10 by default. Now that's a bit like, okay, out of the box, I need to be on 20 meg of RAM and have 500 items in the queue. Server's already broken, right? When it's kind of that low, you would have already been experiencing problems. It doesn't really work like that because, and I'll come to this in a minute, when we actually make requests, the SharePoint server sends back information in the headers as to the current health score of the server. So in the HTTP headers, it will say, let's say it's got 500 meg free, 501 free, so the health score would kind of be 1 at that point, 0 to 10. And it's got 16 requests in the queue. It does some kind of weird math multiplication there as to where it sees the health score as being, and then it will say, right, health score is 2 in this scenario. It returns that in the headers for the request. Now, a browser may not be able to act on that, but something like SharePoint Workspace or the search crawler will say, hang on, the health score's 2. I'm not going to do anything about what I'm doing. Hang on, the health score's 7. Maybe I want to back off a little bit. And again, I'll show you that in a second. So when the server gets to a throttling state, when it gets to a health score of 10, what we actually do is we start throwing 503 errors back to the browser saying, you know, no, the server's busy, you can't actually do any more with the server. And we throw 8032 as the event ID for that. Now, of course, if you've got load balancers and so on, you can kind of avoid this by having them manage this for you. But if your entire farm's got to a state for various reasons where it's kind of denial of service or you're just under extreme load, this will hopefully look after you and allow the servers to recover. It's kind of that catch-22 scenario where you want to serve some requests, but you don't want the servers to go down completely. So this stops the servers from going down completely, but obviously some users are going to get blocked. But it's better to see a message saying server too busy, right, than to see a message where everything is just broken and you just don't get anything. You get a 404 or something like that. Now, how does that work? So how does it actually work from the client side? Well, in SharePoint Workspace, we have the idea of adaptive sync. So when a health score goes back of, say, and this is open and closed workspace, if the workspace is open, so we actually got the home, we've got a workspace for our site home, basically, or a team site or a project that we're working on. If it's open and currently open in the client, what we'll do is, when we're at 6 or above, basically, we'll start throttling back on how often we make requests to the server. If it's closed, we do that a bit earlier, because if it's closed, the user they're not working in the space actively, so they don't need to have it updated as much. So what this actually means is, SharePoint Workspace will back off. It won't keep hitting the server to try and sync. Now, by default, an open workspace is 10 minutes, a closed workspace is 20. When we get to, I don't know, health score of 9 here, or 8, for example, we can see that we're kind of getting to like 30 minutes and 60, 70 minutes respectively. So we're throttling back the number of requests, which hopefully should aid the server in terms of helping it recover. Now, obviously, this is just a SharePoint Workspace scenario, but of course, with Search or any of your own custom applications, you can use that header information to throttle back as and when you need to. So that's a pretty cool feature, I think. Now, again, there's meant to be a demo on that. I will try and do that on my laptop afterwards. The SharePoint Health Analyzer. So the SharePoint Health Analyzer, how many people have heard of this? Okay. How many people have used the Best Practices Analyzer from 2007? How many people thought it was good? Lots of laughs and smugs and whatever else there. Yeah, it kind of didn't get dropped, but it didn't get looked after enough, right? Microsoft kind of started creating health rules and so on, but it kind of was like, oh, SharePoint 2010 is coming around the corner. Let's actually do something better with this. Let's integrate it directly into the product. So now we actually take we kind of based it on the Best Practice Analyzer, but we basically take rules. So out of the box, there's 64. There was talk there was going to be more, and these rules kind of become enabled as you enable more and more SharePoint services, like service apps and so on. And SharePoint would automatically detect problems, let's say, with using the same service account. You know, you're using the same service account, or a database has grown too large, and it will flag this in Central Admin and say to you, hang on a minute, you've got to fix this. This isn't good. It's going to cause performance or security or whatever other issues in your environment. Some of those rules have an automatically repair option, so you can just tick automatically repair, and it will just fix the problem for you. Some of those rules obviously require a bit of manual intervention, like the managed service accounts being used for different services. You don't really want a server changing that for you, right? So that is a really cool tool. The ability to actually repair directly within Central Admin or from SCOM is cool as well. So SCOM doesn't actually have to load up Central Admin. You don't have to go in there and do the work. It has a kind of built-in tool that allows you to push this information into SCOM and then make these changes from SCOM as well. So maybe the guys that look after the monitoring side of things can fix these outside of the SharePoint environment, which might be handy for some of you. So they fall into 4 categories: configuration, performance, availability, and security. So out of the box, if a health rule kind of lies in the security area, that will be that example with managed service accounts being used for one or more process, for example. Availability may be that there is a problem with a service because it is stopped and it's not running and we don't know why, and you need to try and fix that. So again, they kind of are grouped into categories just for logical reasons, because it doesn't make sense to show all these items in one single category. So there's 64 rules out of the box. Again, if you don't enable all the service apps, you won't see all the rules. So don't be shocked if you only see, say, 37. It's probably because you don't have all the services enabled. And when I say 64 out of the box, I mean if you just do start wizard, create all your service apps, off you go. If you've got like project installed and so on, and the Office web application software and so on, you'll probably find that this will start to creep up. And I'll be very surprised if Microsoft doesn't start to ship these in an ongoing basis in cumulative updates and definitely in service packs. So you'll probably find that these health rules will be updated on a continual basis based on the feedback we get about the product and based on, our internal statistics that we take from our support calls and so on. Now, there are timer jobs that are scheduled to run these tests. So there's timer jobs that run and say, right, some of the tests obviously run like every day. Some of the tests might run by the minute. It really depends on the kind of severity that you classify that test under. If it's something like a service account being configured wrong, maybe once a day or once a week's okay, because in reality, you don't want to be checking that all the time. But if it's like service is down, you want to run that like every couple of minutes, right? So there's various timer jobs that fire off and do this work for you. Now, of course, if the timer service fails, what really happens there, right? You can't detect that the timer service has failed if there isn't a timer job to check that for you, okay? So you kind of need to watch out on that one, yeah? That kind of falls back to traditional monitoring from that point of view. But that is how it works out of the box. Now, you can modify and create your own rule definitions. And I'm going to try and show you a demonstration of creating your own rule definitions for example, a web.config, where you set the compilation attribute to the debug setting to true, which means you're running in debug mode. And it will detect that, flag it, and actually automatically fix it if that happens. Again, I don't think I'll be able to run that demo today, but I will make sure I do it tomorrow now. So, SCOM 2007 integration, how does that look? What's the story here? How many people had 2007 management packs for SharePoint installed with SCOM and played, and how many people liked? Thought so. So again, that was a weak area, and it wasn't something that was particularly good, a good story for Microsoft to have there in terms of monitoring. Now out of the box, we actually ship management packs for SCOM for SharePoint 2010 right at RTM. When the product ships, they'll be available. And they do a lot more than what we previously could do. So not only can we monitor multiple farms in one context, not only can we monitor multiple servers, services, go right down to the sort of lowest level of the farm, we can actually flag those SharePoint health monitoring rules directly within the SCOM interface and then act on them from within SCOM. So we don't have to leave SCOM to do any work, okay? Obviously, we can do the standard stuff with performance counters and so on, and we can actually mine data from other sources like the logging database. So we can go into the logging DB and say, right, I want to actually look at, I don't know, the ULS entries, or I want to go back and look at the SQL statistics and so on and so forth, yeah? There is an integration element there, again, kind of a bit of custom work required, but you can do that. Those of you that know SCOM well will know that you can author your own management packs and you can customize these things quite nicely. Now, luckily, I have screenshots of this. So here we can see from an internal example, we've got a farm group, and we've got various farms up there. So we've got SharePoint config, 3 farms, if you like, at the top there. We've also got our configuration database, our server groups. We can see the rule group for the health monitoring, SPME is what it was called in beta. And we can drill down like we used to at various levels, such as services, okay? If we were to drill down into, say, an individual farm and an individual set of servers, we can look at the various service applications for them. So you can see user profile service, claims-based authentication, whether they're healthy, what the story is behind them. So again, out of the box, we do all that work. If we, again, drill down into them, if we drill down from a logical point of view, which is something that we couldn't do previously to this level, is we can see our web apps, but we can also see beneath those web apps the database state, site collection state, site state, pinging of those sites, all the information that we need about the health of those sites from within SCOM, okay? So a lot better than it was before. And then this SPHA, so the Health Analyzer Rule Group, if we've got any health rules that are causing problems, we'll see a red X there, and we can actually fire up the Health Analyzer Explorer, basically, the Health Explorer, that shows us all of those rules that have failed. So here, the server farm account should not be used for services and so on, okay? So we can fire that up, we can view those issues from within SCOM, and then we can fix them either from within SCOM, or we can flag that internally and get our SharePoint admins to look at that. Now, what I'm going to do is I'm going to take questions quickly, and as I'm taking questions, I will try and reboot this machine into Win 7 and at least do some of the demos that I was hoping to do. Again, I'm sorry about that, but I have no idea what's going on with the tech here. So any questions? Quiet room. Yes. When you say does it support log shipping, what do you mean?
SharePoint 2010. So can you do log shipping in 2010 to something like LogLogic or something like that?
So you can, from a SQL point of view, and that's as far as kind of I've looked into it, you can log ship using SQL Server to another SQL Server, and we actually now support taking those logs, applying them, and updating the config, the sitemap, dynamically without having to do a detach and a reattach. Oh, log shipping as in the logs, as in... what we can do, obviously, with the web front ends, we can just point them at just a network path. So we can point all the logs at a network path and have them all in one location. When you say log shipping, you can use the WSS logging database with all the data from all the servers in there and just pull it out of there. It's in there anyway, so you might as well just use that and do a query against that, rather than do your own work in terms of mining the ULS logs in their raw format. The logging database actually only stores critical exception and monitorable type level issues in there. You won't get verbose type entries stored in the logging database taken from ULS. Okay? Yeah. Right, okay. It'd probably be worth having a chat about that afterwards. But if there isn't, whether you speak to them and ask them about that, there's absolutely no reason why they can't do that because, like I said, it's kind of an open API, the logging database, so the infrastructure that is there, it's just whether or not the vendor chooses to hook into that for their product. Okay? This is coming back online now. Any other questions? No? Okay. We're fairly close to time there. What I'm going to try and do is, like I said, reboot this. I'll say I've officially finished the session now. Again, I'll try and get some demos up for those of you that are still in the room until we're out of time. What I will do, though, is tomorrow I might try and repeat the session in terms of just the presentation, the demos for you. The demos were kind of the killer point in this session, and like I said, there's a bit of a tech issue here. So I'll try and do that tomorrow afternoon now, okay? Thanks, everyone, for that. If there's any other questions, do come up. Like I said, if I can get some demos up in a minute, I will do. Okay?